Next, we want to simplify this expression. To do so, we will apply integration by parts. And integration by parts is nothing different than the reversal of the product rule. Remember, the product rule was defined by the derivative of u times v is nothing else than u times the derivative of v plus u prime times v. If we want to rewrite that, we can do so by saying that u times v prime is equal to u times v prime minus u prime times v. Okay. And now what we have to do is we have to find our u and our v. X is u and g of x is v prime. Okay? Then we can write here u times v, and here we have u prime. U prime is the first derivative of x with respect to x, is nothing different but 1, times v, and v is just g, capital G of x. Okay? That is how we get from the first line to the second line. In our next step, we want to rewrite this expression. And we do this by first plugging in the upper limit and then the lower limit. If we plug in the upper limit for x, then we get g of c upper bar times c upper bar. And if we plug in the lower limit, namely c, we get g of c times c. Now, to get from here to there, we only exploit that g of c upper bar is 1. That means the probability that my strongest competitor has costs that are smaller than the highest possible costs, that probability is just 1. Next, now we have the equilibrium bidding strategy as a function of the cost distribution of the strongest competitor. But now we want to express it in terms of the individual cost distribution functions. Okay? And we exploit the fact that the probability that my strongest competitor has costs smaller than x, and I mean I have n-1 competitors, this probability is equal to 1 minus the probability that all of my n-1 competitors have costs larger than x. In the first step, we just replace g of x by 1 minus 1 minus f to the power of n-1. And we end up with this expression. In the next step, we want to simplify this expression, and first of all we multiply c by 1 and by 1 minus fc to the power of n-1. Furthermore, we split up this integral and get this expression. Now, in our next step, we take the integral from c to c upper bar of 1, and this is nothing different than c upper bar minus c. And what we see is that this cancels out with this. Now in the last step on this slide, what we do is we just multiply this term with what we have in the bracket, and we get that our optimal bit is just c plus this integral divided by this term. Finally, we want to derive the equilibrium bidding strategy for the concrete case where my competitors have costs uniformly distributed between 0 and 1. If this is the case, then for each competitor, the probability that this competitor has cost smaller than x is just given by x. If we use this fact, then we can just replace f of c by c and f of x just by x. We can take the integral, and the integral of 1 minus x to the power of n minus 1 is nothing else than minus 1 minus x to the power of n divided by n from c to 1. In our next step, we first plug in the upper limit 1 for x, and we get 1 minus 1 to the power of n, and then we plug in the lower limit and get 1 minus c to the power of n divided by n. What we can see is that we have 1 minus c to the power of n divided by 1 minus c to the power of n minus 1, meaning it just remains that we have 1 minus c divided by n, and if we want to, we can rewrite this to get this final expression.